If you like these videos, please check out my full course at www.lsat.totaltestprep.net with tons of clearly explained actual LSAT questions written by someone who's mastered test and helped others master it, and an evaluation period where you only pay if you want to continue.
All right, so in this video, we're going to cover how conditional logic appears in even more complex scenarios. So, how is formal logic relevant to more complex conditional statements? Now, the conditional statements don't only appear in standard if-then statements, so how do we deal with multiple elements in the conditions? Okay, so we know that the sufficient condition, or rather, the sufficient condition could have multiple elements joined by both and or. So you can have multiple elements in the sufficient condition. Think of it as multiple sufficient conditions. That's one way of looking at it. So the sufficient may have multiple elements joined by and. So for example, if A is in box 1 and B is in box 1, then C is in box 2. We'll draw that out by having A1 and B1 and then arrow C2. So what this is telling us is that in order for the sufficient to be true, both elements have to be true. Now, what does that mean? Well, that means that in this diagram, putting A and B together, we've made the sufficient condition true. So they're both there, which means that the sufficient condition is true. Well, if that's the case, the sufficient is true. Well, what does that tell us? That C's got to be in 2. Okay. Now, if one or the other elements is false, or if both of them are false, then the sufficient is false. So we've got a situation in these three remaining possibilities. Maybe A is in 1, B is in 2. So it's not the case that they're both in 1. Or vice versa. Or maybe they're both in 2. So once again, these are all the different possibilities in which it's not the case that A is in 1 and B is in 1. However, just because the sufficient is false, remember, this means that we don't know anything about the necessary. So once again, the conditional relationship is that if the sufficient is true, the necessary has to be true. But that doesn't tell us what happens if the sufficient is false. You could have another rule that will get us to C being in 2. So we actually don't know where C is going to go in the rest of these diagrams. We can't say, a lot of students will immediately think that it's that if A and B, if it's not the case that A is in 1 and B is in 1, that means that C can't be in 2. No. Once again, all that tells you is that this sufficient is not true, which means the conditional has not been activated, which means we don't know anything about the necessary. Okay, so for the contrapositive, if the necessary is false, that means one or both elements are false. And this takes us back to what we did in the previous video with respect to and or. Remember, if A is in box 1 and B is in box 1, then C is in box 2. So the negative is you flip and negate. So you're trying to say if C is not in 2, then A is not in box 1. Rather, then it's not the case that A is in box 1 and B is in box 1, which means it's not the case they're together, which means that one or the other, or maybe both, is not in box 1. And you can capture that with the or. So not A1 or not B1, as opposed to drawing out A1 and B1, the whole thing crossed out. We just immediately transformed into this because it's easier, because as you'll see in a second, it's easier to recognize when you're looking at the diagrams. So if we look at the diagrams, we see that this is captured by the situation where we've got C in 1 in all of them. C is in diagram, is in group 1 in all of them. So that means that the sufficient is activated. So then you know that it's not the case that A is in 1, or it's not the case that B is in 1. So that means that you got to have one or the other missing from 1. So we've got B in 2, so that satisfies it. We've got A in 2, so that satisfies, even though A is in 1 here and B is in 1 here. So this is a situation where we see that it's not the case that A is in 1 or that B is in 1. So if both were true, then the sufficient would be true and the necessary couldn't be false. So if you had a situation like this, where you had a situation where A1 and B1, A was in 1 and B was in 1, well then you'd have C in 1 and the two of them in 1, which would have that contradiction. Okay. Now, the sufficient may have multiple elements joined by or. So that's what we see here. We see here that it says that if A is in box 1 or B is in box 1, then C is in box 2. Same thing with, or rather, same thing drawn out, A1 or B1, arrow C2. So in order for the sufficient to be true, only one of the elements has to be true. So this is the difference. This is or. Remember, or means at least one, perhaps both, but at least one. So only one of these has to be true. If you've got a situation where only one of them is true, you get to C being in 2. If the other is false, or if they're both true, or if we don't know anything about the other, then the sufficient is still true. As long as you know that one of them is true. And once again, this means that maybe both, then you know the sufficient is true. So in this situation, we've got A in 1 in the top left, B in 1 in the top right, A and B both in 1 in the bottom left, which means that C is going to be in 2 for all of them. Okay. Likewise, as like I said, if you have a situation where you just have A in 1, you know C's in 2. If you have just B in 1, you know C's in 2. And once again, if they're both in 1, you know that C's in 2. If both elements are false, or we don't know anything about them, then we still don't know anything about the necessary. So if we have a situation where we've got A and B over on the right, that does not necessarily mean that C cannot be in 2. Remember, that just tells you that that just tells you that this conditional has not been activated. It's activated if A or B are in 1. If they're both in 2, then it's not activated. But it does not mean that it's false. It does not mean that the necessary condition is also false. Okay. So, the sufficient condition may have multiple elements over here. Or exactly, for the contrapositive, if the necessary is false, that means that both elements were false. So intuitively, this is because if one or the other is in 1, then B is in 2, then C is in 2. Well, if you know that C is not in 2, you didn't have a situation where one or the other was in 1. And this is kind of what we were getting at with what or means, how to translate the whole thing into where you're switching the or into the and. It's basically saying since you don't have one or the other, that means you don't have at least one. That means that neither of them were there. So if C is not in 2, you couldn't have had A being in 1 sending it to 2. You couldn't have had B being in 1 sending it to, or both of them. So you know that neither of them are actually going to be in 2. And what that tells you is that if C is in 1, you know for a fact that A and B are going to be in 2. And once again, if one or both of them was true, then the sufficient would be true and the necessary couldn't be false. So you know that they both have to be false. You know that they're both going to be over in 2 because the necessary is false, because we're dealing with the contrapositive where C is not in 2. And if you have these diagrams, you know that they're incorrect because you can't have C and A over in 1. You can't have C and B over in 1. You can't have C, A, and B over in 1. Okay. Now, the necessary condition could have multiple elements joined by and or. So the necessary may have multiple elements joined by and. So if A is in box 1, then B is in box 2, and C is in box 2. This is a situation where we have multiple elements in the necessary condition. You can think of it as like multiple requirements or multiple consequences. You would diagram it the same way. You would just put A1, arrow B2, and C2. And when the sufficient is true, then that tells you that both elements in the necessary have to be true. That's what it means when you've got and in the necessary. So sufficient is true, they're all going to be true. So if A is in 1, what do we know? We know that B and C are both in 2 because it tells us if A is in 1, B is in 2, and C is in 2. For the contrapositive, to make the necessary false, then one or the other or both have to be false. So the contrapositive of this would be we would have to negate B2 and C2. Now remember, what does that tell us? That tells us that B and C are not together in 2. That doesn't mean that they're both in 1. That just means they're not together in 2. So it means that maybe B is in 1 or C is in 1 or maybe both. And you would do that not B2 or not C2, arrow not A1. This is what we had been doing from the opposite end with the other examples, changing the or into the and, but you could change the and into the or as well here. Now what that tells us is that if we've got these diagrams where let's say B is in 1 and A is in 2, you don't know anything about C because it tells us that if B is not in 1 or C is not in 1, then we know that A is not in 1. Well, the C could actually have gone in 2 as well. The B being in 1 is enough to get the A over to 2, so B is not in 2, which means it's in 1, which means it activates the conditional, the sufficient, because it's if either B is not in 2 or C is not in 2. So we have a situation here where B is not in 2. That means that A has to be in, it cannot be in 1, which is in 2, and the same thing for the rest of these. C is not in 2, B and C are not in 2, so we know that A is going to be over in 2. But we don't know this is what the situation is with C. We don't have to. All we know is that this has been activated. It tells us if B is not in 2 or C is not in 2, well, B is not in 2. So it's activated, so that means that the necessary is true, so that means that we're fine as far as that is concerned. Now, the necessary may also have multiple elements joined by or. So we have the same thing. We just change that up a little bit. If A is in 1, then B is in 2, or C is in 2. And when the sufficient is true, that means that one or the other or both, but not necessarily both, elements in the necessary have to be true. So keep that in mind, one or the other or both, but you don't have to have both of them. So if A is in 1, then B or C are in 2. So you can have a situation where A is in 1, B is in 2, A is in 1, C is in 2. You don't know where the other one is. And you have a situation where A is 1 and B and C are both in 2. Okay? Can you have a situation where A is in 1 and B and C are in 1? Well, no. That's the thing that's ruled out, because it tells you if A is in 1, B or C have to be in 2. So you don't have to have both in 2, but at least one of them has to be in 2. So that means they're both in 1. There's a problem. Now for the contrapositive, to make the necessary false, then both of them have to be false. So once again, just looking at, we've got it here, looking at it intuitively, it tells us that if A is in 1, then B or C is in 2. Well, the negative of either B or C being in 2 is that they're both not in 2, that they're both in 1. So B is not in 2 and C is not in 2. If that's the case, you know that A couldn't have been in 1 because at least one of them had to be in 2. And if none of them are in 2, then A is not in 1. So it's the same thing we've been dealing with the logic of the contrapositive. And so we have a situation here where they're both in 1, which means that A has to be in 2. All right. So to quickly summarize, the sufficient and necessary conditions can have multiple elements joined by and or. If the sufficient or the necessary has and, then both elements need to be true for it to be true, whether it's a sufficient or necessary. And in the contrapositive, either one or the other element has to be false. So that's where you change the and into the or. Now, if the sufficient or necessary has or, then at least one of the elements has to be true for it to be true. And in the contrapositive, both elements have to be false because it's or transforms into and.